we are just simplifying each expression. So working with exponents, which is actually what our study island topic is this week. So it's good to pay extra attention to this problem. I'm just going to rewrite part A so I have room to do and show my work. So I have 3, or I guess I have the quantity of 3x to the 4th and then x to the 3rd. So in this case, what I'm going to be doing is I have this, you can see I have this 4 outside of my parentheses, and that 4 is going to distribute to each term inside of my parentheses. So what we have here is we have 3 to the 1st power, x to the 1st power, right? Because even though the powers aren't written in as 1, it is implied or assumed that it's just to the 1st power. So we have to distribute that 4 to our 3 and our x. So what we are going to have is 3 to the 1 times 4th power. So 1 times 4 is 4, so we have 3 to the 4th. X to the 1 times the 4th power, which 1 times 4 again is 4. And then we're going to bring down our x to the 3rd. So keep in mind, when these terms are mushed together like this, really what there is there's multiplication in between each term. It's just implied. So we can actually take this one more step further to simplify. So we could do 3 to the 4th. And when we're multiplying, we know that we are going to add the exponents. Base stays the same, so x to the 4 plus the 3rd, which is going to give us 7. So our final answer here will be 3 to the 4th, x to the 7th. You could, if you simplified this 3 to the 4th, that would give us 81, x to the 7th, which would be okay, but that kind of defeats the point of exponents then. So this would actually be, this one here is a preferable answer. All right, so that's all for part A. For part B now, again, I'm going to copy this out. I'm going to use a different color so everything doesn't blur together with the last problem. So we have 2 to the 4th. I want to fix that 4. I don't like that. Okay, 2 to the 4th times 3. And that is all over 2 to the 3rd times 3 squared. So in this case, this fraction bar that we have right here, that means the same as division. And when we are dividing, we subtract exponents. So again, my 3 on the top does not have 1. That means it's a 1. So again, bases stay the same, subtract the exponents. So 2 to the 4 minus 3 is just going to be 2 to the 1st, or just 2. You can write 2 to the 1st, but typically in math you will not see it just because it is implied. And then we're going to have 3 to the 1st minus 3 to the 1st minus 2nd power. So it's going to be 3 to the 1 minus 2, which is 3 to the negative 1st. Now, keep in mind, we cannot have a negative exponent, so we have to take its reciprocal. So instead of having 3 to the negative 1st, it becomes 1 over just 3, or 1 over 3 to the, 1 over 3. So if we take that, we combine it with what we have over here. Remember, we're multiplying straight across, and I've already taken care of this division bar here. So if we're multiplying straight across, I'm going to make my 2 a fraction. We would just have 2 times 1/3, because remember, any number I put over 1, the value doesn't change. So 2 times 1 is 2, And 1 times 3 is 3. So our answer here would be 2/3. And then finally, I'll use another color for this one as well. Part C, we have 4 to the negative third times 4 to the second. All right, so since we're multiplying, we want to add those exponents. We want to add the exponents. Bases stay the same. So base stays the same. We're going to have 4, and then we would have negative 3 plus 2. That gives me a 4 to the negative first power. That's not going to work. So remember, all we have to do is take the reciprocal of 4. So the reciprocal of 4 would be 1/4. That gets rid of the negative for us, and we have our answer. Okay, that's all for 9 133.